Good evening and welcome to lesson 8.5. Alright, in the last lesson 8.4 we classified triangles and we learned that all triangles have two classifications. One by the type of sides they have and whether or not they have equal sides, and the other is by their angles. Okay, and we know a lot about triangles. We deal with triangles a lot, so we're very specific when it comes to triangles. What today's lesson is going to be about is classifying other polygons, things with more than 3 sides, so 4, 5, 6, 7-sided polygons. All right, so let's start with the definition of what a polygon is. All right, so first, a polygon has 3 things that have to be true about it. It has to be a closed figure. Okay, so let me start with an example of a polygon. Okay, here's a polygon. Okay, this one's actually a pentagon. So it has to be a closed figure. In other words, there can't be any gaps. It has to go all the way around. It has to be made up of 3 or more segments, and that means line segments. It has to be straight things. So things that aren't polygons. Okay, this would not be a polygon because it's not closed. Okay, this would not be a polygon because it's not made up of segments. Okay, so that's the first 2 criteria. It has to enclose a space. Okay, and it's got to be made up of line segments. The last one is very specific, but it's important. It says each segment intersects exactly 2 others at each of its endpoints. Okay, and let's look at some things that we don't want to be polygons that this kind of avoids. Take for instance an asterisk. Okay, that's made up of segments. Okay, now you could argue it's not really closed. But if I draw it like this, now it does have a closed area in the center. Even though it's got pieces sticking out, it is closed. It is made up of segments. However, those segments don't cross at their endpoints, so we don't want that to happen. We also don't want this to happen. We don't want a bow tie. So there's a segment, there's another segment, there's a segment, and then this one crosses back across. Okay, so no matter how you look at that, so if you look at it as 2 long segments that cross each other, well, the problem with that is each of this diagonal segment, let's make a different color, this green one right here, would touch both of the vertical ones and the diagonal yellow one. So it crosses 3 segments. That's not okay. If, on the other hand, if I think of this as kind of a dented in 6 segment figure, well, then we've got another problem. Let's take, for instance, this piece right here, just this piece right here, and if this is a segment, it would touch this segment, this segment, this segment, this segment. So it touches 4 other segments. So either way, this would not be a polygon. So we don't want any of these things on the bottom, below the blue line, to be polygons. So again, they need to be closed figures, made up of straight line segments, and each line segment has to meet exactly 2 others, and it can only touch them at the endpoints. Okay, so that's what a polygon is, and below the blue line is what a polygon isn't. All right, now, in terms of naming polygons, we name polygons by how many sides they have. And this is a picture right out of your book, and these are the main ones you need to know. Now, we already talked about triangle last night. Okay, quadrilaterals are the most common kind, and we're going to talk about those in more detail in just a second. Other ones that you're responsible for knowing, if a polygon has 5 sides, think about the building down in Washington, D.C., where all the military decisions are made. That's called the Pentagon, because if you look at it from the top, it does in fact have 5 sides. Another good example of a pentagon would be a pedestrian crossing sign like that one right there. Okay, that would be a pentagon. Now you could argue that these rounded corners down here make it not really a pentagon, and you'd have a good point there, but let's assume that they're actually sharp. Okay, a hexagon is a 6-sided figure. You most likely have seen those on bathroom floors, especially old bathrooms, old tile bathrooms. Okay, so there's a hexagon. Octagons, of course, are stop signs. They have 8 sides. And you also need to know decagon. Now, there are names for the other ones, like a 7-gon is called a heptagon, H-E-P-T. A 9-sided polygon is called a nonagon. 11 would be an undecagon. 12 would be a dodecagon. Those of you that take French are probably familiar with those names. In any case, there are names for lots of different polygons, but we are perfectly content if you just know these 6. And in all honesty, you already know triangle and quadrilateral. So really, you just need to make sure that you know the bottom 4. Okay? So again, a polygon is a closed figure that's made out of line segments such that each segment crosses 2 others at each of its end, or intersects 2 others at each of its endpoints, and they're named by how many sides they have. All right, so this symbol here looks a lot like the Domino's pizza logo, and it's a really handy diagram for classifying quadrilaterals. So let's talk about all quadrilaterals. All you have to do to be a quadrilateral is you have 4 sides. So in general, we're going to start with that being like the parent. Think of this like a family tree. So any polygon with 4 sides is called a quadrilateral. Okay. A very specific kind of quadrilateral is kind of interesting. It's called a kite, and it's where you have two pairs of equal sides and they touch each other. So usually you have a long pair and a short pair, and the pairs that touch each other, the equal sides actually touch each other. So it actually ends up looking a lot like a kite. Now you have other kinds of kites too. You can have a kite that's dented in like this, but it's kind of the same idea. You got two pair of long sides that are touching, and you got two pair of short sides that are touching, and in both cases they're equal. So that's a kite. Okay. Over on the other side here, we have a trapezoid. Okay, and you know what trapezoids look like. Trapezoid is a quadrilateral where you have a pair of parallel sides. Okay, and that's pretty much it. A little bit more fancy, you have something that's called an isosceles trapezoid. I'm just going to abbreviate it. And an isosceles trapezoid is basically the one you're probably picturing. That's the one that not only has parallel sides, but the non-parallel sides go out like this, and they're equal in length. Now, technically, when you get into geometry, there are some problems defining an isosceles trapezoid with equal sides. So what we're actually going to do, you'll learn another definition later on where you actually define the base angles to be equal, but it accomplishes the same thing. Okay? Then we have the ones you're more familiar with. Okay, we've got a parallelogram, and I'm going to spell it, so I'm going to squeeze it in here. It's parallel. Okay, remember parallel, the middle L's are parallel L's. That's how you can remember how to spell it. Okay, parallelogram. And a parallelogram is like a rectangle that's kind of leaning over a little bit. It's got two pairs of equal sides that are across from each other, but it doesn't necessarily have right angles. Okay, if it has right angles, okay, then it's called a rectangle. Okay, you're familiar with that. On the other hand, if the parallelogram, instead of just having opposite sides equal, suppose that all of the sides are equal to each other. Again, doesn't necessarily have to have right angles. Basically, you probably would call that a diamond. The fancy math name for it is a rhombus. Now, that's a little hard to spell. It's R-H-O-M-B-U-S. Okay? And again, these are special kinds of parallelograms, both the rhombus and the rectangle. And then finally, at the very bottom here, you get something that is both a rhombus and a rectangle. So to be a rectangle, by the way, you got to have right angles in the corners. Okay, and I could draw them all the way around, but you get the idea. Same thing with a square. So a square has right angles going all the way around it, but it also has equal sides like a rhombus. So you can think of it as kind of the intersection between a rhombus and a rectangle. Okay. Now, there's something really interesting about this diagram. Okay, if you start at the bottom of it, anything that's above a figure is like a category that the bottom thing would belong to. So for instance, a square is a special kind of rhombus. It's a rhombus that has right angles. It's also a special kind of rectangle. It's a rectangle that happens to have equal sides. Again, it's the intersection of these two. Okay? Sorry, just had somebody knock on the door. All right, go back up from rhombus and rectangle for a second. Okay, parallelogram. So all you have to be a parallelogram, obviously you got to have four sides, and your opposite sides have to be parallel. Turns out they also end up being equal, but the definition is that the opposite sides are parallel. Well, if you look down below, that's definitely true of a rhombus. And so a rhombus is a special kind of parallelogram. It's one where the sides are equal. A rectangle is a special kind of parallelogram where you actually have right angles. You don't need to have those to be a parallelogram. And I can do the same thing going backwards from parallelogram up to trapezoid. Okay, a trapezoid technique. Now this line has a little bit of fuzziness. In some books, a trapezoid is defined to be at least one pair of parallel sides, in which case a parallelogram would be a special kind of trapezoid. In other books, including your textbook series, this line doesn't exist here. Okay, we'll take it out because a trapezoid is defined to be a quadrilateral with exactly one pair of parallel sides, no more, no less. Okay, and by the way, same idea with a rectangle and an isosceles trapezoid. Okay, in an isosceles trapezoid, you do have a parallel sides, and so again, same thing with this green arrow. But that kind of helps you kind of lay out some of the special quadrilaterals. Again, the ones that you need to be responsible for, you definitely need to know rhombus, square, parallelogram, trapezoid, and quadrilateral. Okay, it's a good idea to learn kite and the isosceles trapezoid. Right? Oops, I missed rectangle and rectangle. Okay, so these are the 6 you have to know, and they're all special kinds of parallelograms. All right, I don't want to belabor that, but it is a little bit of vocabulary. There's a good diagram in your there's a good write-up in your book that has pictures of all of these, and you do need to learn that. Okay. And I think that's pretty much it for right now. We'll talk a little bit about how to break down polygons and look at their properties, their angles and their sides, what the angles have to add up to. But that's it for this video. So it's 10 minutes, so I'm going to go ahead and say goodnight now. Thank you for watching, and again, be ready to answer questions about general polygons, specific quadrilaterals, and also the different names of polygons based on how many sides they have. If you know those three things, you'll be in good shape for the daily quiz tomorrow. All right? Again, thanks for watching. I'll see you in class tomorrow.